Video for Unit 2, Lesson 4, Prime and Composite Numbers. So if you look on page 59 at the beginning of Lesson 4, this is what you will see. We learn that numbers multiplied to form a product are factors of the product. So we learned about multiples already. Multiples are numbers that you can get by multiplying one number by something else. So we also learned that all even numbers are multiples of 2. That means they can all be divided by 2. In other words, you can multiply 2 by any other number and you'll always get a multiple of 2. Multiples of 10 are numbers that are that number multiplied by 10, and so they have a 0 on the end of them, like 20, 30, 40, 50, 10. Okay, now factors are the two numbers that we multiply together to make a product. So this is important vocabulary. Factor times factor equals product. Okay, so we can see 2 times 14 equals 28. And we are asked, what are the other factors of 28? So we know 2 and 14 are factors of 28 because when we multiply them together, we get the product 48. Okay, so what might the other factors of 28 be, and how do you know? Well, one way of finding out is if you have memorized your times tables and you think to yourself, well, what numbers can I multiply together to get 28? Because those are going to be the factors of 28. If you don't have those all memorized or they're not as easy to access in your memory, I'm going to show you two other ways that you can figure out what the other factors of a number. One way that you can figure out what the factors of a given number are. You can use tiles. And I have an interactive tool here that enables me to use different square tiles on my computer to model this out. So this square, or this rectangle, this blue rectangle that I'm showing you on my screen represents 2 times 14. It's 2 rows of 14 squares. So that's one way of representing the number 28, and it gives us the factors 2 and 14. To find out if there's other ways of doing it, we can simply move these squares and try and make another rectangle. So we can't have an odd shape like this. This doesn't work, okay? It has to be a regular rectangle with an equal number of squares in each row and column. So what I have here is I have 3 rows, but I don't have an even number of columns because I've got this one square sticking out here. So 3 is not a factor, pardon me, of 28. There's nothing that you can multiply by 3 and get 28. So I'm going to keep going here and see what I might find. Well, look, I found another way of representing 28. There's still 28 squares here. I haven't added or taken any away. But what I have is I have 4 rows of 1, 2, 3, 4, 5, 6, 7 squares. So I've discovered that 4 and 7 are also factors of 28. So I can add 4 times 7 equals 28 to my list. Now, it's your turn. You can play around with 28 tiles using this tool and see if there's any other factors of 28 that I may have missed. I'm going to use these magnets on my whiteboard to demonstrate how we can use arrays to check if numbers are prime or composite. So in the textbook example, they used tiles to see if they could make different kinds of rectangles with a certain number of tiles. And that was one way of checking if a number is prime or composite. If you can make more than one rectangle with it, so if you can make more than one long row, then that number is composite. let's use these magnets to check if some numbers are prime or composite using arrays. So remember, an array is a series of dots or counters or other symbols that we line up in an equal number of columns and rows. So we can't have anything hanging off. It's still going to make a rectangle. So very similar to using the tiles, but a little different, maybe a little easier to do by hand. I don't have 23, so I can't check against the first number they used in the textbook, but let's try 7 to start. So I'm going to take 7 magnets, and I'm going to see if I can make some arrays with those 7 magnets. So I know for sure the first one I can do is one row with 7 columns. So rows go across and columns go up and down. Okay, rows are horizontal, columns are vertical. So I can do one row with 7 columns, and then my 2 factors of 7 are 1 and 7. So it could be a prime number, because the definition of a prime number is it only has the 2 factors, 1 and itself. Let's see if we can make 7 with 2 rows. So I'm going to start taking my counters and lining them up in rows, and I end up with 1 left over. So 2 cannot be a factor of 7 because I have 1 left over. Let's try 3. And I'm in the same boat there. 1 is left over. If I try 4, well, yeah, then I end up in the same problem. So the only way to make an array with 7 counters is 1 and 7. So we can say 7 is definitely a prime number. Let's try something else. Let's use all the magnets, okay? So I'm gonna do one long row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so 1 and 12, 1 times 12 makes 12. So it might be a prime number, but let's see if we can check and see if there's any other factors of 12 to see if it might be composite. So I'm going to start with making 2 rows and see if we have an equal number of counters in each column. So I can make 12 with 2 rows of 6. I'll line them up a little more neatly. So we can say we can do 1 times 12. That was our first solution. We can also do 2 times 6. So right away, we know 12 is not a prime number, it's a composite number because it has more than 2 factors. So let's explore and see if we can find out if 12 has more factors than just 1, 2, 6, and 12. So let's do this again. We are going to start moving counters and see if we can get 3 rows. So it's not the neatest, but we can do 3 rows of 4. So we have another equation that will make 12. 3 times 4. For the heck of it, let's explore and see if we could do a 5th row. No, we can't. All we end up with now is 4 rows and 3 columns if we try to extend. So that's the same as 3 times 4. It's just reversed. 4 times 3 is the same as 3 times 4 because multiplication follows the commutative property, which means you can switch those digits around and it doesn't change the answer. So we know that all of our factors of 12 are 1, 12, 2, 6, 3, and 4. And usually we would write them out in correct numerical order. So we would say 1, 2, 3, 4, 6, and 12.